Hi friends, in this video we are going to discuss Cauchy mean value theorem, which is the generalization of mean value theorem. So here the statement of the theorem says for any two function f of x and g of x, which is defined on the closed interval ab, such that f of x and g of x are continuous in the closed interval ab, and f of x and g of x are differentiable in the open interval ab. Third condition, g dash of x is non-zero for all x belongs to the open interval AB. Then there exists C belongs to the open interval AB such that f dash of C divided by g dash of C equal to f of B minus f of A divided by g of B minus g of A. So here I will explain the same thing with the help of this curve. So here let this gamma of t be the parametric curve which is defined at t as g of t comma f of t, where g of t is my x axis and f of t is my y axis. So here gamma of t equal to g of t comma f of t. So here at starting point of my parametric curve gamma of t is a g of a comma f of a at t equal to a, and the end point of my parametric curve I will denote it as b equal to b is g of b comma f of b at t equal to b. So here at t equal to a, so g of a comma f of a is the starting point of my parametric curve gamma of t, which is defined as this, and at t equal to b the end point of my parametric curve is denoted by b as g of b comma f of b. So here I will draw on second line which join this two point a and b, and just observe one thing. Slope of this second ab is f of b minus f of a divided by g of b minus g of a. This is the slope of my second ab, and so there, according to Cauchy mean value theorem, there exists one c belongs to open AB such that, so here at there exists c at this point is g of c comma f of c. So here this is the slope of this. So there exists one c belongs to open AB such that g of c comma f of c. So there exists one tangent to this parametric curve at this point g of c comma f of c. So here the slope of this tangent equal to, so here slope of this tangent at this point c equal to dy by dx at x equal to c. So here y is the function of t and x is the function of t according to chain rule. So here this is dy by dt and this is dx by dt. So dy by dt is f dash of t, and dx by dt is g dash of t, but at t equal to c, as x tends to c, at t equal to c, so here this is f dash of c divided by g dash of c. Therefore just observe one thing, this second ab with joining this two point of the parametric curve gamma of t is parallel to this tangent. So here if this second is parallel to this tangent t, therefore the slope of this tangent is same as the slope of this second. So here according to this tangent t is parallel to my second AB. So here if this tangent is parallel to this second, therefore the slope of my tangent is same as the slope of my second. Therefore this is my slope of this tangent is same as the slope of this second AB. So here this is the local instantaneous change in f with respect to g. This is the total change in f with respect to g. So here this the statement of the Cauchy mean value theorem says instantaneous change of f with respect to g is same as total change of f with respect to g. So here this is the statement of the Cauchy mean value theorem. Now, so how, when we say that the given pair of two given functions f and g satisfy the statement of the Cauchy mean value theorem. So this is the working rule. First we have to check whether the given function, that is f and g, are continuous in the closed interval ab or not. So we have to check whether the given pair of functions, that is f of x and g of x, are continuous in the given closed interval ab or not. If it is continuous, then move to the second step. Then we have to check whether the given two function f of x and g of x are differentiable in the open interval a b or not. That is, f dash of x and g dash of x exist for all x belongs to this open interval a b or not. We have to check. If it is exist, then move to the third step, that is c. So here check g dash of x is not equal to 0 for all x belongs to the open interval a to b. So here, if all these conditions are satisfied, that is, if f and g are continuous in the closed interval a b and f and g are differentiable in the open interval a b, and third thing, g dash of x is non-zero for all x belongs to this open interval a b, then there exists one c. So here c belongs to open a b such that satisfying this condition. So after that, so if continuous, differentiable and g dash of x is non-zero for all x belongs to OB, then find the c by using this formula f dash of c divided by g dash of c equal to f of b minus f of a divided by g of b minus g of a. With this equation, find the value of c. If that value of c belongs to this open interval a b, then we can say the given function f and g satisfy the condition of Cauchy mean value theorem, or we can say Cauchy mean value theorem is verified by the given function f and g if c belongs to open interval a b. If c is not belongs to this open interval a b, then we can say Cauchy mean value theorem is not applicable for these two functions f and g. So here I will explain one example. So with the help of example, I will explain this the concept of the Cauchy mean value theorem. So here, verify the Cauchy mean value theorem for the function f of x equal to x square and g of x equal to x in closed interval 1 to 3. Now verify the Cauchy mean value theorem for this function. So here I don't have space. I will run this. So, like Rolle's theorem and the Lagrange's mean value theorem, the working rule for the Cauchy mean value theorem, first we have to check whether the given function f and g are continuous, and second working rule, check f and g are differentiable in the open interval a b or not. So here the given is given f of x equal to x square and g of x equal to x, which is defined on here defined on the closed interval 1 to 3, which is given information. F of x equal to x square and g of x equal to x square, which is defined on the closed interval 1 to 3. First we have to check whether the given function f and g are continuous on the closed interval a b, that is closed interval 1 to 3. So here first condition, so here f of x equal to x square, so here this is the polynomial in x. So here all polynomial functions are continuous, so f of x is continuous, and g of x is again polynomial in x, so g of x is continuous. Therefore f of x and g of x are continuous as a polynomial function in x. Here f of x equal to x square and g of x equal to x are continuous as a polynomial in x, because all the polynomials are continuous. F of x equal to x square and g of x equal to x square are continuous as a polynomial in x. So here first condition is okay. Now check both. Check f of x and g of x are differentiable. That is, first find the derivative of f of x. Here f of x is x square. Therefore f dash of x equal to 2x and g dash of x equal to 1. So here f dash of x equal to 2x. So exist for all x belongs to this open interval 1 to 3, and g dash of x equal to 1, that is constant, exist for all x belongs to this open interval 1 to 3. Therefore f dash of x and g dash of x exist for all x belongs to the open interval 1 to 3. So here second condition is also satisfied by the given function f and g. Now check g dash of x is not 0 for all x belongs to the open interval 1 to 3 or not. Now here third condition, here g dash of x which is equal to 1, which is never 0 for any value. So for all x belongs to open interval 1 to 3. So here g dash of x equal to 1, that is constant function. So here this is never 0 for any x. But here that is we have to check for open interval 1 to 3. So here if it is not 0 for any x, so it is not 0 for x belongs to this open interval 1 to 3. So here given function f and g satisfy the three conditions of the Cauchy mean value theorem. Now we have to find the value of c by using this formula. If this c belongs to this open interval ab, then we can say the given function f and g verify the Cauchy mean value theorem. If c is not belongs to this open interval ab, then we can say Cauchy mean value theorem is not applicable for this function f and g. Here now I will find the value of c by using this formula. So for that purpose I already have f dash of x. So here f dash of x and g, I already have g dash of x. Just I will replace c by x. So here I have f dash of c and g dash of c. Now I want to find f of b minus f of a and g of b minus g of a. I have a equal to 1 and b equal to 3. So here a equal to, so here fourth condition, a equal to 1. This implies f of 1 equal to, f of 1 equal to, so here f of 1, f of x is 1 square which is equal to 1 here, and a equal to 1 and b equal to, so here 3. This implies f of 3 which is equal to, f of b equal to f of 3 equal to 3 square, that is 3 square which is equal to 9. Now here in the same way I will find g of a. So here a equal to 1, therefore g of a equal to, g of a means g of 1. So here g of a equal to g of 1 which is equal to, g of x is x, so 1. Now g of b which is equal to g of 3 which is equal to g of x is x, so g of 3 is 3. Therefore f dash of c divided by g dash of c which is equal to f of b minus f of a divided by g of b minus g of a. Now tell me f dash of x equal to 2x, then f dash of c equal to 2c divided by g dash of c, g dash of x equal to 1, then g dash of c is also 1. So this is 1 which is equal to f of b. So here this is f of b is f of b equal to 3, then f of 3 equal to, that is f of b equal to f of 3 equal to 3 square which is equal to 9. So here 9, and f of a equal to 1, f of a equal to f of 1 equal to 1. So here 1 divided by g of b, that is g of b equal to g of 3 equal to 3 minus g of a equal to g of 1 equal to 1 which is equal to 8 by 2 which is equal to 4. Therefore 2c equal to 4, c equal to 2, that belongs to, now here tell me c equal to 2, that belongs to here open interval 1 to 3. Therefore here if c belongs to this open interval ab, then we can say the given pair of function f and g verify the Cauchy mean value theorem. So here I have find 2c equal to 4, c equal to 2, that belongs to the open interval 1 to 3. Therefore f of x and g of x satisfy all condition of Cauchy mean value theorem. Therefore Cauchy mean value theorem is verified for this function f of x and g of x. Thank you.